Hello and welcome to the Perlita Passive House. My name is Xavier Gaucher. I'm the owner builder and the Passive House consultant for this project. I took the Passive House class back in France in 2014. And I must say that after taking the training, it did not make sense for me to build any other way. It allows to reduce energy consumption by up to 75% and increase comfort and indoor air quality drastically while reducing building CO2 emissions. Buildings represent 39% of the total CO2 emissions, and they are a major opportunity to fight climate change, which we need to do now. So when we moved to Los Angeles in 2015, it was the only thing I had in mind. I wanted to build a passive house. And so we found this house, which, as you can tell, could benefit some improvements. It was a 1,100 square feet, one-story house. So to minimize the impact and the budget, we decided to keep the existing footprint. So we kept the foundations and the outside walls and added one story. So now downstairs we have an open living space with a kitchen, a dining room, a living room, an office/guest room, and a bathroom. Upstairs, we have a den, a laundry room, and 2 bedrooms with in-suite bathrooms. And it is 2,100 square feet. Because of the very narrow driveway, we could not add external insulation, which would have been the best way to avoid thermal bridges. So therefore, we did a double wall to have the extra layer of insulation required by your passive house energy modeling. So we have a layer of R15 insulation and a layer of R13 insulation for the walls. For the floor, we have R21 insulation between the floor joists. And for the roof, we have R38 insulations between the roof rafters. And we use standard fiberglass batt insulation. Our biggest challenge was the airtightness, which is one of the important principles of the Passive House standard. So for the floor, we taped the OSB sheets, and for the walls and the roof, we used an airtight membrane, which was supplied by the insulation company. This product made it really hard to meet the airtightness numbers, but we did it after a lot of work, a lot of extra work. So my first advice is stick with products which have been used by experienced passive house crews. Don't try to experiment with unproven solutions, especially on your first passive house project. Same thing with the tape. We switched during construction from the white tape that you see on the picture to the green tape for the same reason. Every connection, every window frame, every penetration need to be sealed. So this is actually why we installed the electrical panel inside the building envelope to minimize the number of penetration. So here is one of the few penetration that we kept for the kitchen island, and that's how it's supposed to be done. Here is our airtight pet door, which we actually had an easier time to find than our airtight high efficiency double pane windows and doors. And here is our sliding glass door, which has a lift and slide system which shields it when it is closed. Airtightness, which is one of the biggest improvements that our construction code needs to make, is quite simple if it is designed properly with proper construction details, easy to achieve on site. So it's more a design issue than a construction issue. That's also what we learned. You control your airtightness level using a blower door, which you can borrow for free from Southern California Edison. And so you do it first during construction when you can access your airtight layers, and then at the end for the construction certification. But at that stage, if you don't meet the numbers, it is too late because you cannot fix the problems. Constant ventilation is also one of the passive house principles, and because it is the only solution to ensure proper indoor air quality. So on our end, unlike in most passive house, because we're in a mild climate, we were able not to use a heat recovery ventilation system. So what we have is that we have a MERV 13 filter and the fan running 24/7, supplying fresh air in the return plenum of the HVAC unit. And we have a second fan extracting air 24/7 as well from the kitchen, the bathroom, and the laundry room, keeping a balanced ventilation system. The entire house is all electric. So here you can see the condensing units for our heat pump system, which is installed under the back patio. And this is the heat pump water heater, which is installed in the basement, which was already existing in the previous house. That's our heat pump dryer, which only requires a 220 plug and no venting. And this is our induction cooktop. We cook a lot, and we have been using induction for over 15 years, and we won't switch back to anything else. And it works well with all my wife's grandmother cast iron pans. We have 16 solar panels. The house is able to reach net zero with 12 panels. And so the 4 extra panels supply the power for the electric car that we use for all our local commutes. We also have a 13.5 kilowatt hour storage battery, which allows us to be off-grid 2/3 of the time, which is actually great during power outage. But it also made me realize how challenging is the all renewable energy transition we need to make, and how energy efficiency is a key aspect of it. I would like to end the tour with this graph which I presented last year at the Net Zero conference. It represents the EUI, so the energy use intensity, which is the energy required from a building per square foot to operate. And according to different building standards for our house, and the number of solar panels which will be required to meet net zero. And what you can see is that today, a code construction can require about 2 times more solar panels than a passive house construction, which actually would pay for a big part of the $22,000 extra that our passive house construction required. Thank you for listening, and I will be looking forward to your questions. Thank you.